Nishant Kumar Karn and I am a second year undergrad student from National Institute of Technology, Agartala. Welcome back to my channel where we will be solving another super interesting question from JEE Advanced. So let's get started. So in this question we have been said that we have a parallel plate capacitor C with plates of unit area and a separation D is filled with a liquid of dielectric constant K equal to 2. The level of the liquid is d by 3 initially. Suppose the level decreases at a constant speed v, then the time constant as a function of time is. So what we are given here is we have a capacitor and that capacitor is filled with a dielectric of dielectric constant K equal to 2. Initially the level of this dielectric constant is d by 3 and this distance is 2d by 3. The area of both the plates is equal to 1 units and the level of this dielectric is decreasing at a speed v. Then we need to find out the total capacitance as a function of time, because only then we will be able to calculate the time constant, because time constant is equal to R into C. So if we need to find out time constant as a function of time, then first of all we need to find out capacitance as a function of time. So let's see what we have to do. So let us understand about the initial conditions first. For the C1 initial, let us consider this is our capacitor. This level is the dielectric constant d by 3 and this distance is 2d by 3. The capacitance of this part is C1 and the capacitance of this part is C2. So C1 initial will be equal to 1 into epsilon naught divided by 2d by 3, which will be equal to 3 epsilon naught upon 2d, and C2 initial will be equal to k into 1 into epsilon naught upon d by 3, which will be equal to 3 into 2 into epsilon naught upon d, which will be equal to 6 epsilon naught upon d. So this will be the initial capacitances. Now we are given that the rate of change of the level of this liquid is v. That means dx by dt, that is the speed, is equal to v, and since the level of the liquid is decreasing, we need to give a negative sign here. Now if we integrate, dx is equal to minus v dt. We need to integrate both sides. The time will be integrated from 0 to t, and x, that is the level of the dielectric liquid, will be from d by 3 to any general value x. So x minus d by 3 will be equal to minus v into t. That means the level of the dielectric as a function of time can be given as x equal to minus vt plus d by 3. So this is the basic equation that will be helping us to solve the question. That is the level of the dielectric as a function of time. Let us consider this as equation number 1. Now for any general case, let us consider this is our capacitance, this is the dielectric with a level x then this level will be d minus x. So C1 as a function of time will be equal to 1 into epsilon naught upon d minus x, which will be equal to, putting the value of x from equation number 1, we get C1 equal to 3 epsilon naught upon 2d plus 3 vt. Similarly, C2 at any time t will be equal to k into 1 into epsilon naught divided by x, which will be equal to 6 epsilon naught upon d minus 3 vt. Now the total capacitance Ct will be equal to C1 at time t series C2 at time t. The total capacitance as a function of time will be the series combination of both the capacitances C1 of t and C2 of t, which will be equal to C1 into C2 upon C1 plus C2, which will be equal to 3 epsilon naught upon 2d plus 3 vt into 6 epsilon naught upon d minus 3 vt divided by 3 epsilon naught upon 2d plus 3 vt plus 6 epsilon naught upon d minus 3 vt. So solving this equation, we get C total as a function of time equal to 6 epsilon naught upon 5d plus 3 vt. So this is the value of the total capacitance as a function of time. Now the time constant as a function of time will be equal to R into capacitance as a function of time, which will be equal to 6 epsilon naught R divided by 5d plus 3 vt. This will be the time constant for the given situation as a function of time. So this will be the answer. So I hope you understood the question and you understood the solution. Thank you for watching. Stay tuned for the upcoming videos.